Hello everyone, I am Colin Kurz, and this is my report for Lab 4. The purpose of this lab was to analyze the behavior of circuits to gain a deeper understanding of their functioning. Several online models were made to model the behavior of the circuits. The lab demonstrated how resistors decrease both overall current in the circuit and voltage at points in the circuit. It also demonstrated how capacitors, when both connected and disconnected to a battery in a circuit, will cause the circuit to have high current initially before reducing the current to zero. The fundamental physics principle of this lab was the concept of a circuit. Potential difference is stored in a battery, which creates current in the wire flowing from one terminal to another. Resistors can be placed in this circuit, which cause a drop in voltage. Capacitors can also be added to a circuit and will either charge or discharge depending on their charge and if there is a battery present. Ohm's law is also important. It states that change in potential is equal to current times resistance. Also, going all the way around a circuit will result in a zero change in potential. In the lab, anything in the circuit is the system, while there are basically no surroundings since it is a digital experiment. For the first circuit, the circuit was set up with two 1.5-volt batteries, two ammeters, a 47 ohm resistor, and a 100 ohm resistor. Because the potential difference in the circuit due to the batteries should be 3 volts and the resistors add up to 147 ohms, Ohm's law predicted that the current in the circuit should be 0.0204 amps. The ammeters showed that this was correct. When an ammeter was reversed, it read the same current except it was negative. When an ammeter was replaced with a voltmeter connection in the middle picture, there was no current and the potential difference was 3 volts. This is because the circuit is open, so there is no current. It is essentially an extension of the batteries. Going back to the top picture, potential difference between each point in the circuit was measured with a voltmeter. The results are shown in the graph. They added up to zero like they were supposed to. The ammeter reading stayed the same during this because the voltmeter adds no current, voltage, or resistance to the circuit. When an ammeter was placed in parallel to the 100 ohm resistor, the current increased to 0.06 amps because the current essentially went around the resistor. Finally, the resistance of several components was measured. There's a potential sig-fig error in these calculations. The next circuit consists of a battery, 10 ohm light bulb, and a 200 milliflorins capacitor. Both when the capacitor was connected and when it was disconnected from the battery, the light bulb brightened initially and then dimmed. This same trend happened to the current when the battery was connected and disconnected. The time it took for the capacitor to charge and discharge with the 10 ohm light bulb was recorded. This was also recorded for the 20 ohm bulb. As expected, the charging and discharging times for the capacitors in each of the circuits were similar. A potential error may have occurred here with human error in the recording of time it took for the current to charge and discharge the capacitor. The circuit was similar to the discharging circuit on the last slide, except the bulb was 30 ohms and there was a voltmeter attached to the capacitor to determine the potential difference across it. Using a graph of the natural log of the potential difference versus the initial potential difference over time, it was determined that RC was equal to 5.988 seconds. An alternative way to measure RC was to multiply the resistance by the capacitance, or 30 ohms by 0.2 florins. This yielded a similar result of 6 seconds. These values are similar within a margin of error, showing the soundness of the potential measurements. Some final questions remain. For the first question, real ammeters do have some amount of resistance. While small, it would have afflicted this amount of resistance onto the circuit, changing the current and potential changes in the circuit. For the second question, the model predicts the capacitor to reach full charge extremely quickly with no resistors in the circuit. This would not happen in real life since wires have their own small resistance, which wasn't included in the model. However, it would still charge rather quickly.